And this is the last topic of this notebook. It is the short-time Fourier transform, widely used in signal processing, and is basically a discrete Fourier transform applied to short blocks of the signal. So we take our signal and we divide it into overlapping blocks. Each block has a length of n, and the overlapping is defined by the hop size m. So here is the analysis equation. So we have m is the block index and h of n is a window function. In the synthesis part, we have the synthesis equation, and the overlap blocks, they are added up, which is called the overlap add. And also the window has the overlap add property defined here, that it's equals to 1. So we can see the short-time Fourier transform as a filter bank with non-critical sampling. That's usually m is smaller than n, so the overlap, the hop length is smaller than the block length. So in literature you find the window function applied only in the analysis part, but applying it into the synthesis part, it improves the resulting synthesis filters, and it's more similar like usual filter banks. So here's a Python example. So we will take the short-time Fourier transform of a sequence from 0 to 31. So this is our signal. We will use the SciPy STFT function. So we're taking a block size of 4, and the default overlap is block size divided by 2. So this will result in 3 subbands downsampled by 2. So here is the result of the short-time Fourier transform. We have the frequencies of the FFT subbands. So we have 3 subbands. We have the times of the subband samples, and we can reconstruct by taking the inverse STFT, and we get our signal back. So here's one last example. We will take the short-time Fourier transform of an audio file. So I'm loading the audio file with SciPy like we did before, converting it to mono, taking the short-time Fourier transform like we did in the previous example by using different parameters, and then I'm plotting using pyplot p-color mesh, and it gives us a spectrogram very similar to the one we had before in the first examples when we used the matplotlib pyplot spectrogram function, and we also used librosa to have the short-time Fourier transform and the spectral to plot the spectrogram. So that's it for this notebook. We've seen uniform and non-uniform filter banks, and then we went through many frequency transforms that we will be using during the course and in all these Jupyter Notebooks tutorials. And that's it. See you next time.